Good morning, SRT. Yes, this is the third and final type of question for momentum in Physics 12. It involves two dimensions, unlike Physics 11, which was one-dimensional. And in this situation, it's not a collision, not like the first type of problem and the second type of problem. This one is an explosion. And here is the question. On an icy lake at New Year's Eve, so you're thinking no friction, horizontal surface, a stationary 1.00 kilogram firework explodes into three pieces, all moving horizontally. So they didn't move up or down, they just moved horizontally across the lake. The first piece, the mass 1 is 0.25 kilograms, moves to the east that way at 31 meters per second. The second piece, M2, which is 0.45 kilograms, moves to the south at 44 meters per second. What's the velocity of the third piece after the explosion? That's the question. Just as in any collision or explosion, the law of conservation of momentum must hold true. So that says the initial total momentum has to equal the final total momentum. We have three pieces. They're stuck together in the firework, M1, M2, and M3. And their initial total momentum has to equal the final total momentum of the three of them after the explosion. If we take a look at the initial total momentum, none of them were moving. Like they were all stuck together to start with to make 1 kilogram, and they weren't moving. So they had a mass of 1 kilogram, but they had no velocity. They weren't moving at all. So the initial total momentum was 0. And that has to equal the final total momentum after the explosion. After the explosion, we said that one of the particles, M1, is moving in that direction at 31 meters per second. So this is P1 final, and P2 final, the momentum of the second object was down in this direction, and it was its mass, which was 0.45 kilograms, times 44 meters per second. So we had one particle going this way, one particle going that way. Probably no surprise that the third particle got pushed out this way somewhere. And that would be P3 final. Let's just check and make sure though. P1 final plus P2 final plus P3 final have to equal 0. So if I go P1 final and add P2 final to it, I'm just right where P1 final ends, I'll add P2 final to it, right here, and right where P2 final ends, I have to go back to P1 final. And yes, that is in the same direction that we predicted it to be. So right where P2 final ends, if I add the final vector, so the final momentum of that third mass, third piece that got blown off, it is going in that direction. And that is P3 final. And the bottom line is 0 was no momentum. They had none at all. And if you add up that momentum, P1 final plus P2 final plus P3 final, it really does come back to 0. That is what the law of conservation of momentum says. If it was 0 to start with, you have to add these vectors together, these momentum vectors, so that they will close and make a triangle. There will be no opening in there. So it's a totally closed triangle. That one plus that one plus that one comes right back to the beginning, so right back to 0. After calculating some numbers, I've got P1 final. It's just mass 1 times V1 final. The mass 1 was 0.25 kilograms. Its velocity was, or speed was 31 meters per second. So we get 7.75 kilogram meters per second. So this really should be 7.75. And similarly for P2 final, it's just M2 times V2 final. So 0.45 times 44, and that was 19.8 kilogram meters per second. So I've got this side, not drawn to scale, and I have to find out what this hypotenuse is. I do know that there is a 90-degree angle here because this one was going west, or east I should say. This one was going south, and there is 90 degrees between the two of them. So P3 final will be the hypotenuse, and I will also have to find out the angle that this is moving at, because it'll be not going north-west, it'll be from north, some theta west of north. So we have to find out theta as well. Okay, and we'll do that right now. Using the calculator to go through the math, this side right here is the hypotenuse, so h squared equals a squared plus b squared. So h squared is equal to 19.8 squared plus 7.75 squared, we got here. And when you do that, and then don't forget to root it, you get 21.3 kilogram meters per second is the hypotenuse. Is that P3 final, which is the final momentum of the third piece, is 21.3 kilogram meters per second in that direction. So we know that this P3 final is M3 V3 final, and that's how we can find out what the velocity is, because we've got M3 V3 final is equal to 21.3. We know M3, it's just 1 kilogram minus 0.25 kilograms minus 0.45 kilograms, because it's the only piece left when you take away M1 and M2. Checking to make sure we've got the right number for M3, because M3 times V3 final is equal to 21.3. And sure enough, we had M1 being 0.25, M2 being 0.45 kilograms, and those two plus M3 equals 1. So just 1 minus 0.25 minus 0.45 is equal to 0.3 kilograms for M3. So we can use that number and just put it over onto this side here, and we've got 0.3 times V2F is equal to 21.3. And that will give us our V3 final equal to 21.3 divided by 0.3, which is 71 meters per second. So V3 final is equal to 71 meters per second. We're almost there. We also need to find out this theta angle, and we'll do that right over here in a second. Just doing the calculations, tan theta, that angle right here, is equal to opposite over adjacent, so TOA. T is opposite over adjacent. And we get 7.75 divided by 19.8. Do that number, get a decimal, shift tan or inverse tan, and we get 21.4 degrees. So it's not going northwest, it's going from north 21.4 degrees west of north. So it's really 21.4 degrees west of north. Speed, 71 meters per second. Angle, 21.4 degrees west of north. And that is that.